Hi and welcome to the session. Today we will learn about polynomials. Let us start with the degree of polynomials. If p of x is a polynomial in x, then the highest power of x in the polynomial p of x is the degree of p of x. Let us take an example for this. Suppose we have a polynomial p of x equal to 3x to the power 4 minus 2x square plus 7. Then here in this polynomial the highest power of x is 4. That means degree of p of x is 4. Now, a linear polynomial is a polynomial of degree 1. An example of a linear polynomial is 2x minus 3. A quadratic polynomial is a polynomial of degree 2. One example of a quadratic polynomial is 2x square plus 5x minus 3 upon 5. Also, the general form of a quadratic polynomial is ax square plus bx plus c, where a, b and c are real numbers with a not equal to 0. And a cubic polynomial is a polynomial of degree 3. One example for this is 2 minus x cube. Now, general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers with a not equal to 0. Now let's start with zeros of a polynomial. A real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. Here, for the polynomial p of x equal to 2x minus 3, 3 upon 2 is the 0 of the polynomial p of x. Now, a linear polynomial can have at most 1 0, quadratic polynomial can have at most 2 zeros, and cubic polynomial can have at most 3 zeros. Now let's study the geometrical meaning of the zeros of a polynomial. The zeros of a polynomial p of x are the x coordinates of the points where the graph of p of x intersects the x-axis. Here we have a graph of p of x which intersects the x-axis at 2 points whose x coordinates are minus 2 and 2. So the zeros of p of x over here are minus 2 and 2. Similarly, in this graph, the graph of p of x does not intersect the x-axis, so here p of x has no zeros. Now let's see the relationship between zeros and coefficients of a polynomial. Let's see a quadratic polynomial first. The general form of a quadratic polynomial is ax square plus bx plus c. Now let us suppose that the zeros of this polynomial are alpha and beta. Then sum of zeros, that is alpha plus beta, will be equal to minus of coefficient of x upon coefficient of x square, that is minus b upon a. Similarly, product of zeros, that is alpha beta, will be equal to constant term upon coefficient of x square, that is c upon a. Now let's take one example for this. Suppose we have a polynomial p of x equal to 3x square minus 2x plus 5. So sum of the zeros, that is alpha plus beta, will be equal to minus coefficient of x upon coefficient of x square, that is minus of minus 2 upon 3, which will be equal to 2 upon 3. And the product of the zeros, that is alpha into beta, will be equal to constant term upon coefficient of x square, that is 5 upon 3. Let us consider a cubic polynomial now. The general term of a cubic polynomial is ax cube plus bx square plus cx plus d. Now let us suppose that the zeros of this cubic polynomial are alpha, beta and gamma. So sum of the zeros, that is alpha plus beta plus gamma, will be equal to minus coefficient of x square upon coefficient of x cube, which is equal to minus b upon a. And the sum of the product of zeros taken two at a time, that is alpha beta plus beta gamma plus gamma alpha, will be equal to coefficient of x upon coefficient of x cube, that is c upon a. Lastly, the product of zeros, that is alpha beta gamma, will be equal to minus of constant term upon coefficient of x cube, which will be equal to minus d upon a. Now let's take one example for this. Suppose we have a polynomial p of x equal to 2x cube plus 5x square minus 9x plus 7. Then alpha plus beta plus gamma will be equal to minus b upon a, that is minus 5 upon 2. And alpha beta plus beta gamma plus gamma alpha will be equal to c upon a, that is minus 9 upon 2. Similarly, alpha beta gamma will be equal to minus d upon a, that is minus 7 upon 2. So this is the relationship between the zeros and the coefficients of a polynomial. Now let's see what is division algorithm for polynomials. Division algorithm states that if we are given polynomials p of x and g of x with g of x not equal to 0, then there are two polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. Now suppose we have a polynomial p of x equal to x cubed minus 7x squared plus 12x minus 6 and g of x equal to x minus 1. Then by dividing p of x by g of x, we can get the values of q of x and r of x, such that p of x, that is x cubed minus 7x squared plus 12x minus 6 will be equal to g of x, that is x minus 1, into q of x, that is x squared minus 6x plus 6 plus r of x, that is 0. So this is our division algorithm, and with this we finish this session. Hope you must have understood all the concepts related with polynomials. Goodbye, take care and have a nice day.